Near Shoemaker spacecraft touchdown in the saddle region of 433 Eros, becoming the first spacecraft to land on an asteroid. Near-Earth asteroid rendezvous, Shoemaker, near Shoemaker, renamed after its 1996 launch in honor of planetary scientist Eugene Shoemaker, was a robotic space probe designed by the Johns Hopkins University Applied Physics Laboratory for NASA to study the near-Earth asteroid Eros from close orbit over a period of a year. It was the first spacecraft to successfully orbit an asteroid and also land on an asteroid. In February 2000, the mission succeeded in closing in with the asteroid and afterward orbited it several times. On February 12, 2001, the mission succeeded in touching down on the asteroid. It was terminated just over 2 weeks later. The primary scientific objective of NEAR was to return data on the bulk properties, composition, mineralogy, morphology, internal mass distribution and magnetic field of Eros. Secondary objectives include studies of regolith properties, interactions with the solar wind, possible current activity as indicated by dust or gas, and the asteroid spin state. This data will be used to help understand the characteristics of asteroids in general, their relationship to meteoroids and comets, and the conditions in the early solar system. To accomplish these goals, the spacecraft was equipped with an X-ray/gamma-ray spectrometer, a near-infrared imaging spectrograph, a multispectral camera fitted with a CCD imaging detector, a laser rangefinder, and a magnetometer. A radio science experiment was also performed using the NEAR tracking system to estimate the gravity field of the asteroid. The total mass of the instruments was 56 kilograms, 123 pounds, requiring 80 watts of power. A previous plan for the mission was for it to go to 4,660 Eros and do a flyby of 2019 Vanelbada en route. In January 2000 it would rendezvous with Eros, but instead of staying it would visit multiple asteroids and comets. Some of the choices that were discussed were 2P/Anchor, 433 Eros, which became the mission's primary target, 1036 Ganymed, 4 Vesta, and 4015 Wilson Harrington. The small body Grand Tours a plan for visiting 2 asteroids and 2 comets over a span of a decade with the spacecraft. The primary goal of the mission was to study the near-Earth asteroid 433 Eros from orbit for approximately 1 year. Eros is an S-type asteroid approximately 13 times 13 times 33 kilometers in size, the second largest near-Earth asteroid. Initially the orbit was circular with a radius of 200 kilometers. The radius of the orbit was brought down in stages to a 50 times 50 kilometers orbit on April 30, 2000, and decreased to 35 times 35 kilometers on July 14, 2000. The orbit was raised over succeeding months to a 200 times 200 kilometers orbit and then slowly decreased and altered to a 35 times 35 kilometers retrograde orbit on December 13, 2000. The mission ended with a touchdown in the saddle region of Eros on February 12, 2001. Some scientists claim that the ultimate goal of the mission was to link Eros, an asteroidal body, to meteorites recovered on Earth. With sufficient data on chemical composition, a causal link could be established between Eros and other S-type asteroids, and those meteorites believed to be pieces of S-type asteroids, perhaps Eros itself. Once this connection is established, meteorite material can be studied with large, complex, and evolving equipment, and the results extrapolated to bodies in space. NEAR did not prove or disprove this link to the satisfaction of scientists.